Tēnā koe nā hoa. Quick video today looking at sprites and walls. This is coming straight out of the tutorial on the arcade website. So if you head on over there, you'll be able to see a lot of what I'm pulling from today. But one of the things that I really wanted to show you first up is that the arcade library actually has a whole lot of built-in resources to make your life easier when you're just starting to learn this stuff and you're starting to develop it. Get to know the library. So it's actually when you import an image and you give it a directory to where your image is, you can actually just replace that with this here. And Python will know to go looking inside the arcade library and it will find all of these fantastic images here. A lot of them are from Kenny, like the ones we've been using so far, and we have downloaded those images locally so far. But today we're going to use some from the arcade, internally inside the arcade library itself. So the one we're going to want today is, whoa, where are we going? We're going down to the boxes. I had them all lined up and then I moved. Where are they? Come here, boxes. Here we go. Box, crate, double. Now, it's really important to know how big your tiles are when you're making a game with arcade. And so we're going to check out how big this is. How many pixels is it wide? How many pixels is it high? And I can do that by going inspect. And I'm on Chrome. And because I'm on Chrome, it's going to load up this really handy box image here. And you can see, for some reason, it's given me a very interesting thing here where it's going 127.997 pixels by 127.997 pixels. It's 128 by 128 pixels wide and high. Very important that if you are bringing assets in, particularly earth and ground and boxes and crates, things that you're going to repeat over and over again, that they're a power of 2 wide. It's going to make your life so much easier. So very handy that this is 128 by 128. We're actually going to halve it today to make it 64 by 64. That's an important thing to take a note of. Okay, let's go back, because I need to remember the actual URL to get here. Cool. Right, I have some code here. Now let's make this a bit wider for you. Whoa, where'd you go? There it is. I have some code here, and I have simplified this code right down. Normally I like making code together, but today I'm going to explain it really quickly. What we're doing here. We've written code like this 5 times already, so I thought it would be okay to just start with some basic code. We have imported arcade, made ourselves some width, height, and title, and we've given ourselves a player scaling constant there to make sure our player is not too big. We have made a game class. This is where all the magic is happening. Of course, you've done this before. We've done this before together, where we have created an init function, where we're setting up, we're calling the init in our superclass, which is, of course, arcade.window. We are giving ourselves a blank placeholder variable for self.player, and we're going to fill that in later. And we're setting our mouse to not visible. We're giving ourselves a setup function here, that whole thing, where we're loading in a sprite character, we're setting its position on those 2 lines, and we're setting the background color to Amazon, that lovely arcade.color.amazon color. We have an onDrawer function, and all that is doing so far is starting the render cycle, drawing the player. Okay. We are not doing anything on our update function, but we'll need it later, so I thought I'll put that in there and just pass. Not going to do anything. Forget about it. Ignore it, please, Python. And lastly, I have set the player up currently to follow the mouse motion. So on mouse motion, set the player center X to X, set the player center Y to Y. That's it. And now, these 3 lines, we're going to do something a little bit different with them next video. Not going to overload this one. Let's keep it short. Next video, we're going to do something different with these. But for the moment, we're creating a game by calling that class, setting into that variable, running the internal setup function, and then telling arcade, run everything. That's our base code. That's what we're starting with. Our plan today is to get some walls in here. What have we got so far? So we're running it, and hopefully it should boot up for us. Potentially. Let's kill that terminal. I think one of the things with making these videos is that I'm capturing a lot of video feed. I'm running OBS, lots of things that are going on in the background, and it really, really likes leaving me hanging while I'm on screen. So here we go. A player, Amazon background, it follows the mouse. She follows the mouse. That's all. But I want some obstacles in here. I want some boxes that appear on the screen and also that our player can interact with or that are barriers for our player. So let's close this. Okay. First thing we're going to do is let's get a box on the screen. We know how to do this already. We've done this with coins. And so let's say self.wall list is going to equal none as a placeholder. And then on setup, we're going to say self.wall list is going to equal arcade dot sprite list. And let's, whoa, I'm mixing things up here. That is not a good place to put that in. Let's put it in here so that we do everything with the player in the same place and then everything with walls in the same place. Okay, so let's say wall is going to equal arcade.sprite. And sprite is a class, so it's going to have a capital. And here's that magic thing about arcade having images already stored in it. We're going to go quotation marks, colon, resources, colon, slash, and back we go to Chrome. No, not slash. Colon, resources, colon, images, slash, tiles, slash, box crate double.png. I think we can remember that. Go away, Chrome. I hope we don't need you later. Images, slash, tiles, slash, box crate .png. Okay. And we're going to, like I said, it's currently 128 by 128. We're going to halve that to 64 by 64. So in order to do that, we need to scale it down by 0.5. And already something should be screaming out at you saying, you're putting in a literal here. Why? You should have a variable here. We'll fix it. Don't worry just yet. Wall.center x is going to equal width divided by 2. Somewhere in the middle. No, exactly in the middle. Wall.center y is going to equal height over 2. And we're going to say self.wall_list.append. And we get wall. Cool. That's the way that we know and love of how to put sprites into arcade. We've done it with coins. We're actually going to do it quite a bit differently soon. But for the moment, let's get this working. Change our on draw. Self dot wall list dot draw. And on update nothing. Save it, run it. Module object is not callable. I made sprite list wrong. Sprite list, for some unknown reason, I believe is camel case in arcade. No, it's not. It's Pascal case? Is that what we call that? All capital letter for each word. In init, we're getting an error here in line 21. Unable to locate that image. Oh no! I was sure I got that right. Box crate double.png. Box crate double.png. I should have kept the Chrome tab open, but we got it. Yes. Okay, cool. Okay, so we have a box on the screen. We have a player. They can't interact at the moment. Now, we could do some really advanced maths here and say, well, if the player's X is less than the box's X plus its width, and collisions are hard. Python Arcade makes them easy. It has a built-in physics engine which can sort all of this out for us. It is magic. You do not want to be writing your own code to handle collisions. Make your life easy. Use the physics engine. How do we do that, I hear you say? Well, I'm glad you asked. All of this is available in the tutorials, in the reference on learnarcade.academy. And that's where we're going to go. Okay, so first thing we need to do is we need to, in here, say self.physics engine. And set that to none. Again, this is a placeholder just in case you change it somewhere else in your code. When you run setup, it's going to be refreshed into whatever you actually want it to be. So under setup, which is getting quite big now, which is fine, we're going to set self.physics engine to arcade.physics engine simple today. There are other ones, and they have their pros and cons. Today, we're just going simple. Okay. Take a look at what the IntelliSense is asking me for. All the way over that side, it's saying the first thing it wants is the player sprite. The next thing it wants are the walls with a wall list. Okay, let's give it what it's after. So the first one is self.player, and the next one it wants is self.walllist. Awesome. That's almost it. The last thing we need to tell it is to actually update that physics engine in our own update function. So down here, where we were saying define update, is we're going to say self.physics engine.update. And let's go. Whoa, okay. We you can tell there's something going on. I think this error is because I'm using the mouse position, and I'm not actually updating the player on each cycle, and I'm only updating the physics engine. Perhaps what we should do is, instead of using the mouse to control our player, let's go back to what you would normally do and use the keyboard controls to update the player instead. Okay, this will be a nice quick change. Shouldn't matter too much. So instead of on mouse motion on key pressed, and again we get rid of all of that garbage that the IntelliSense gives us. So we want the modifiers, we want the we want the symbol as well. If symbol equals arcade dot key dot left self dot player dot change x equals -1, -5 today. Let's make it a bit faster. Okay, copy that. This is where you could pause the video and see if you can remember how to do this all by yourself, and then join back up with me once I've finished. We're going to say arcade right, and we're going to change that to 5. We're going to copy that whole thing. Oh, I should add, as we're doing this, just recently in VS Code, the Python interpreter has been merged with Pylance. I was using Pylance to start with, and normally you would have been using just the normal Python interpreter. IntelliSense, autocomplete, all of that good stuff that happens in VS Code. They're now merged because Pylance is excellent, and now they are using Pylance as the default. Up goes change Y, goes 5, and down change Y goes -5. Okay, we also need to self dot player dot update, and let's just exit that because I accidentally opened Python. By the way, I've seen almost every student I've had do this at some point. I've done it at some point, and I've done it right now and not realized that I have. I've actually opened, just by key bashing, I've opened Python in console terminal mode. And you just get out of it by saying exit. I'm sure if you've gotten this far, you've probably done it too. But we can all have just a chuckle about that particular issue. Yay! Here we go. Okay. Yeah. Whoa! I haven't set the on-key released, which I think is hilarious. But, as you can see, my player is actually hitting that box. Let's change the on-key release, because that's silly. Define on-key release. There it is down there. On-key release. If key, if symbol equals arcade dot key dot dot left, or symbol equals arcade dot key dot right, self dot player dot change x is going to equal 0. Grab that whole thing. This makes me wonder that there must be a way to make it operate sensibly with mouse motion. That must be a thing that happens. I don't know why that wasn't happening today, but I will do a bit more investigating. And you should too, to see if you can make a mouse-controlled game where the physics engine and the walls work. Arcade.key.up or arcade. Or symbol equals arcade.key.down. Self.player.change y is equal to 0. Save it. Run it. There we go. That's a bit more sensible. And we can't go through the boxes. Collisions are working. There is an obstruction. Look at that. Excellent. We should leave it there for now in a nice tidy little box. It's where we have gotten some boxes onto the screen using the arcade resources location in our URI, in our directory, our image directory. And we have a player which is keyboard controlled, which cannot move through it. That's going to be important for later. Okay, I will see you in the next video. Ka kite a popo.